Welcome to the Pharma Toppers, friends. Today I'm going to tell you what are the rules for predicting or prediction of the drug absorption. Generally, the pH partition hypothesis is that which can give good idea regarding the drug absorption. But certain rules are that, like Lipinski Rule of 5, then maximum absorbable dose, then MDR-like rule. These all are the rules which can predict, which can give us idea regarding the drug absorption will take place or not. And from that, today I'm going to explain you the two rules, that Lipinski Rule of 5 and what are the further changes, the extended Lipinski Rule of 5, and the second one is the maximum absorbable dose. So here, first of all, Lipinski Rule of 5, what does it include? That as you all know, that Lipinski Rule of 5, all things are there in multiplication of the 5 only. There should be less than 5 hydrogen bond donor, should be less than 10 hydrogen bond acceptor, and molecular weight should be less than 500. The partition coefficient should be less than 5. So this is the Lipinski Rule of 5. Here, why this rule came to existence is that we know that it is ranges are there, that if the higher the hydrogen bonding is there will be chances of the lower lipid solubility, and the lower lipid solubility, then that means it won't pass through the GIT from intestinal side to the systemic circulation. So if the compounding having the more than 5 hydrogen bond donor or acceptor, they are more prone to formation of the hydrogen bonding with the aqueous part, and it won't pass through the GIT membrane. If the molecular weight is higher than 500, then it will be the problem for the passive diffusion. The molecule cannot pass through by passively, provided that the molecule having the higher molecular weight and it is still having some transporters which can transport it, so it can be possible. And log p value, as you know, the log p value should be less than 5. It's greater than 5, then it's a very high lipophilicity and it won't pass at all, because solubility is also there, it should be required for the absorption. So any drug molecule which violating any of this rule will not recognized as a drug or not forwarded as a drug in case of the pharmaceutical industry. And for further convenience and further new tools led to the extension of this rule to the extended Lipinski Rule of 5. This extended Lipinski Rule of 5 have this all parameters somewhat modified. Along with that, some small molecules, they are considered as like that partition coefficient log p value is extended from 0.4 minus 0.4 to the 5.6. The number of atoms, including both donors and acceptors of hydrogen bonding, should be less than 20. Sorry, not less than 20, around 20 to 70. Then further one more thing, these two are included. Then molecular weight is now not less than 500, but it is in range of 180 to 500. These three quantities are already there, and the further extension, the further new quantities which are added are the molar refractivity. This molar refractivity should be in between 40 to 130. Then one more thing is the polar surface area is added. The surface area of the polar components of the molecule, it should be less than 140 angstrom square. And further, the last quantity which was added is the rotatable bonds, and it should be less than 10. As you all know, the rotatable bonds allows the flexibility and increase the solubility, increase the aqueous counterpart. So this is all about the Lipinski Rule of 5. The next is the maximum absorbable dose. This is the quantity of the maximum dose which can be absorbed from the GIT. If your dose of the drug is greater than that of MAD, then it won't absorb. So dose of your drug should be less than MAD, which is the maximum absorbable dose, and maximum absorbable dose can be calculated by means of the solubility at the pH 6.5 into dissociation coefficient of the molecule, which is measured by means of the cacao 2 cell line. Then small intestinal fluid volume, and the small intestinal transit time, which is generally considered as the 4.5 hours or 199 minutes is the efficient time for intestinal transit time. So value of this will give you the dose, MAD, maximum absorbable dose, and value of MAD, value of your dose should be less than that of MAD for absorption to take place. Should be less than that of MAD to better absorption to take place. There are certain rules, MDR like rule and other rules, which I have not explained here. You can go for the surfing of that rules, but these are two the most extensively used rule for checking out what is the absorption status of the drug molecule before giving it in vivo. So thank you. For further videos, please subscribe Pharma Toppers. Thank you.